Okay then, so today we're looking at the volume of solids and looking at some formulas for volumes of solids. We've done our exercise to begin with and identified which ones of these are prisms. A prism has the same cross-sectional area all the way through the height. So this one was a prism, this one was a prism, these are all prisms, these are all prisms, because we notice that the shape at the top is the same all the way through the height. So the shape at the top here is a circle, it's the same all the way through. Here we have a triangle on the top, it's the same all the way through. So to find the volume of a prism, once we find the cross-sectional area of the top, we multiply it by the height, because it continues the same all the way through, and we get the volume. So with this first question we're looking at, we need to find the volume of the triangular prism. We have this shape on the top, so the area of that one multiplied by the height will give us the volume. So the volume in this case is going to be 0.5 times 12 times 12 times the sine of 130 multiplied by the height. Now the height in this question, it shows us here, is going to be 15. So multiplied by 15. We put that into our calculator. Let me pull my calculator up, it's over here. So we need 0.5 times 12 squared times the sine of 130 times 15. Rounding to three significant figures. Rounding to three significant figures, that should be 827. And that would be centimeters. That would be centimeters squared. I can't put the squared in. Where is my little toolbar? Oh, because I'm a fool. Of course it's cubed. Centimeters cubed. Okay, so that's volume of prisms is quite straightforward. We have 3 or 4 new formulas to look at on this part of the course. So the volume for a right pyramid you'll find on the formula sheet. The volume for a cone you'll find on the formula sheet. For a cylinder and for a sphere. Typically, you're going to get questions on cylinders, cones, and pyramids. These are the most common ones. Very popular, this topic also for optimization. Very popular, this topic for optimization. Looking at the formula sheet, we can have a quick look over our formula sheet. So when we get to the geometry section of the formula sheet, you've got the volume of the things that are quite straightforward, like the cylinder and the prism. But on new formulas, the volume of a right pyramid, the volume of a right cone. Right cone is a good one because it's very tricky to use when you're using the surface area. Very common. I think this to me would be the most popular one. That one. Volume of a sphere. So let's have a go at some questions. Find your formula sheet. Find the relevant formulas. See if we can use them for these two. I'll give you 6 minutes for this one, so it takes a little bit longer. Any solutions to these ones? So we've got 2 problems to solve here now. Our first one is a right pyramid. A right pyramid. So how do we find the area of the right pyramid? Let's have a look at let me pull up the formula sheet for this one. So we want this one. It's 1/3 times the area of the base times the height. So we need our volume to equal 1/3 times the area of the base is going to be 4 times 3.5 times the height, 7.4. Apologies for the multiplication symbol I'm using there. So we get 1/3 times 4 times 3.5 times 7.4. Did we get this? 34.5? 34.5. Oops. 34.5. And this will be centimeters cubed. How about B? If we look at our formula sheet for B, this is the volume of a right cone. So we need 1/3 pi r squared h. So what is the height? What is the height in this shape? We don't know it. How can we find it? Pythagoras' theorem. So from Pythagoras, we're going to get 11.5. Oop, they're back. Squared.
No, it's also Pythagoras. I think it's Pythagoras.
Is equal to 3.2 squared plus h squared. This is going to give us h is equal to, let me do this on the calculator. I'm not going to end solve it, but I'm guessing most of you guys did. So we want the square root of 11.5 squared. Do we get 11.0?
Yeah.
So this is 11.0. And then what is the volume? So the volume was 1/3 times pi times r squared. So r was 3.2 squared times, and what was the height? 11.0. So let's take this on the calculator now. 1/3 times pi. We'll find that down here on the bottom left. That's pi. Times 3.2 squared times, oops, move down, times, and I'll just scroll up and use the exact value that we got here. And we get 118. 118. Are we in centimeters again? So centimeters cubed. All right. So that's it for today. Have a go with exercise 2H and 2G.